this is important because this vector is perpendicular to these two. Okay? So cross product of course, all these cross products are perpendicular to the vectors, right? But it turns out when you do all this, and it's easy to prove, that the cross, and we're not going to prove it today, we're just doing an overview, right? Just getting a couple of key ideas in that'll make the whole course go much easier. The cross product can be proven to be perpendicular to the two vectors. This is for any cross product. It's always perpendicular. Okay? It's another reason I cross I is 0. What's perpendicular to both I and I? Well, the whole plane, no vector, right? Any vector in the JK plane is perpendicular to the I vector. So you don't have a cross product. Okay, well, cross product is perpendicular to two vectors. So is approximately perpendicular to the top of our three-dimensional figure. Okay? Well, we call this a normal vector. And I would put the word approximate in there. Okay? Our approximate normal vector. Now we say approximate because if I used these two vectors, remember this vector isn't exactly the same as this one, right? Okay? So we're going to get something a little different, but it's like we've got a 0.01 here where we had a 0.02 here. Okay? And if we use this vector, we got maybe a 0.31 instead of a 0.32. Something like that. You can see what they are. You look at it carefully. Okay? Now, so that's why I say approximate. But there ain't going to be much difference. Okay? Because, you know, our 0.01 gave us a 0.002 and all that stuff. So it's very, very close to uniform. Now remember, this is an approximation of a curved surface. Okay, the curved surface that represents that function f of x, y, right? So we don't expect these vectors to be exactly parallel, but we used a small interval, 0.1. So they came out pretty close. In the limit, you get a normal vector at this point, which tells you exactly the perpendicular direction at the 0.11. If you shrink that 0.1 down to a 0.01 to a 0.001, you know, let it be a delta x and a delta y and let them both approach 0, you'll get a normal vector that's practically the same as this one. Okay? And one reason that's important is if we want to find the surface area, well, let me talk about that in a separate video.